we can do another function. Okay, this one we're going to have to read through to know how to create the expression. So we want to take in a node and send out a node. Right? So we're taking a node and we're sending out a node. How that's done, it's up to the code. So take a node and return a node. So here's our node func. So node func dot invoke this node that we're taking in. Alright. Take in a node. We don't return a node, we return a bool. I'm sorry. Alright. Take in a node and return our bool. Nah, that's not what I wanted to do. I do need to take in a node, but I do need to return a node. So this is the node that we're going to be returning. And we're going to be checking its weight. Okay. So node func invoke node weights greater than 0. We can check for null. Makes sense. So let's see how we can use this one. How about we use it on the left node? And let's close that off there. So left node. What does the left node do? It's going to take a checking. This is what we want. And we're going to pass in, we're going to take an n, and we're going to return an n. Now, we need a key selector. Alright? Yeah, so that's an int, and that's an int. So take a node and let's just go with the float. So func for x and the func for y. We should be able to pass in a key selector, and I think that's what this is. Alright. So we can run with that and see. So they both take in and they return a node. They take a node, return a float. Take a node, return a float. And then we get the node. So we have an in node, and we're checking. We're not going to do this. We're going to use our funcx invoke on the in node. And our funcx we're going to invoke on the in node, our func-y, excuse me. Right, so now we have our node to work with. And if the node doesn't equal null, or the node and the node's weight is greater than 0, then we return that. So how will this look now? We're taking a node, and for the x, we're going to return this value, n, title, and for the y, let's do that also. We're going to return this value. Hang on, if I can just grab a hold of it. Okay, so now that defines our left node. So we have pretty much two choices. Of course, we can just pass this in right here, but you know, that looks nicer to me. And there's a lot less lines of code too than even passing this in. So cool. Let's go with the expression model. All right. They both work the same. You know, I couldn't say which one's faster or not. You know, we can just remove the invokes from here, and we have a nice tight little function set. Right, so I'm gonna go with the top one, and we'll check it, see how it works. So we're cutting corners here, and we're seeing if we can cut corners here. What we need to return is x alone and y negative. Simple enough. All right. Making a mistake here is not an option. You make a mistake here, and everything gets, you know, as screwed as it can possibly be. So we want a plus on the y. They need to mirror these exactly, because that's what it's doing. Actually, I can just do that, and then we can close off this one. Why are they different? Should be the same. Okay. So that's right, that's for this one. That's wrong, and it needs to be -1. Why is that? The left node is checking y. Oh, okay, that's a plus. That's right. Okay, so we have minus and nothing. And that's fine, just as it is. 1, 2, 3, yeah. Okay, let's do the next one. Let's do it like that. So here is our up. Let's that off. And we're checking against -1 and x. Okay, let's get the next one in 9. Oh, this is creating like big spaces. That's a pretty confusing check there. Okay, so we're checking plus x and no y. Some of them are pluses, some of them are minuses, some of them are nothing. Yep. Okay, let's move on to the next. So I'm refraining from removing them because if it's buggy, I can come right back here and see whether things do or don't match up. Okay, now let's do the top guy. I think this would be the last one. So we're only checking for plus on the x. That seems to be the same thing that I did already. Hang on. Plus on the x. Here's a plus on the x and no y. So we're checking right node. Oh, it is a right node check. And bottom node. So if there's a bottom node check, it would look the same. Okay. So you know, these should be else if statements, right? Or I should be returning after each one that oh, they have to return. I'm sorry. So I may need to return this. I have to do an if check. Hang on. It doesn't actually tell me what corner it's cutting, right? So if I'm in here, I can return or that. Because I don't care which one works. I just need them, one of them to work. And I do check the first one always. So that's what I'm doing here. I'm checking the first one. And then I'm checking the second one if the first one fails. This is a short circuit. If this one fails, it continues. If it passes, it doesn't continue. So that's the pattern we need to follow for the rest of them. So let's return. Let's do a nice little tab. And let's carry our piece down here. And let's pour that out. So that's it. That's cool. And to make it even more efficient, we can also, let's say we have a left node. We can just make this a call that takes a checking and then gives you back a left node. And that way it'll just be a tiny little thing in here that says left node or right node. Or it'll say return left node or bottom node or whatever. So either or that pass will be good. We don't need them both, we just need one. Okay, let's do the same thing here. We're returning this value or that value. And again, for our last chunk. I think it's our last chunk. So return this value or that value. So right node, how many times do we use right node? Once, twice. Bottom node, twice. That's also a right node. Up node, twice. And then I'm assuming left node would be also twice. So we can actually save a little bit by reducing these calls. So if we ask for a left node, we know we're getting this back. And the benefit I can see straight up is not messing up. So for instance, if this is changed, if our left node was wrong, then it will be wrong only in one place, and we can just fix that, right? So, but first we need to check this, make sure it works, and then we'll pull out 4 methods, one for each of the nodes, and we'll use them appropriately. Seems good enough. So yeah, this should work. There's no reason why it shouldn't. We didn't change anything. We just turned each chunk of block of code. So actually, it's the same, right? So we have a node. We have a node. We check if the node is not null, and we get its weight, if it's greater than 0, and if it is, we return true, and if it's not, we return false. And these always return a value. Right? If it comes in here, it needs to return a value because this is the one that it's using. So that should work just fine. And if it doesn't ever reach in here, it's not a corner cutting node. Okay, looks good. Let's compile Unity and check it out. Yeah, while this is compiling, I usually stream between 6 and 8 and then go on for another 2 hours with another project every weekday evening. I'm just on today messing around, see if I can build up some interest for later. I'm thinking of going a few hours earlier than 6, probably around 3, and then make it a guarantee 3 to 8 every evening, and then, the the crowd will carry you anything after than that. So I'm just kind of testing the waters now. But I am on every evening, including tonight, between 6 and 8 p.m. Pacific Standard Time. Figured I'd get that a plug. Alright, so what do we got here? So our aim was to remove those corner cutting methods, and let's just do it this way. Especially for debugging, it's nicer to see things happen than to just have stuff dropped on your lap. Now, of course, this is not the perfect algorithm. There's lots of different ways of doing things. This is what I've come up with. When you learn to write your own, it's probably as never as optimized as the MIT guys can come up with. But sometimes it's not bad. So that's on par with what we used to get before. Let's do this the first time. I want to run threading on the first run and see what it looks like. 0.4, so yep. So now see, we always get the 100th of a millisecond. That's thousandths of a millisecond. That's awesome. So the draw kicks in a little bit extra. So far so good. There is no change. Let's go ahead and rock that one. We can't change it yet. We're gonna make some more functions. So we want one function that takes in a node and it outputs a Boolean. No fancy calls in this one. So bool. So can cut corners. Actually, I'm gonna do the other one so because it checks 2 corners. All right, it checks. No, it's actually 1 corner, huh? Because that's a corner. Okay. Corners is fine. I'm gonna block that one out so I can do a quick rename. So get cut corners goes into can cut corners twice. Undo that. Okay. So now this takes in a node. Oh, it's not a can cut corners, and it returns a bool. It is a left corner, right? So that's what we want. So a left corner is this. Return left corner. And the node we're checking is this. So it's gonna say left corner or right corner. So we have to make sure that's right. That's a left node, that's a left node, that's a left corner. So let's do the up while we're here. Left corner node. right corner node. So our up corner is this method right here, and we're using nodes to check. Okay, so we have an up corner and we have a left corner. Guaranteed to work. Pulled away nice and neat. And there we go. We return left corner node or right corner node. Right. So this now we know works. We can remove it, but it doesn't hurt to double check. So left corner is, I'm checking the X and the Y, and up node is the X and the Y, and they should not change. So let's find another left node, because we're going to be doing another left corner. So the left node is here, and it's the first one we're going to be checking. So we can actually randomize the checking of this to, give it a little bit more flexibility, I guess. Not flexibility, but it will look different. Like when it runs, it give you the same path, but it will check, let's say, the left node first sometimes, or the right node first sometimes. That way, if the two distances are the same, you won't always get the same exact path. You may get a little something different, which will equate to being the same. Has to, right? So we're checking for a left node, and that's our left node up here. Let's remove that. And we're going to create now the bottom node. So let's go ahead and copy bottom. And our data for our bottom node comes from here. Well, our method for our bottom node. So, and that's our bottom node. Let's go ahead and do our check. And let's use our bottom node. I should have left the checking there. Ooh. So that's the node we're checking against. So now we have a bottom node, which we should check, of course. Bottom node is Y plus and X even. We can remove that. Left node stays the same. So we know these two work. Let's continue on. These probably actually tell us what we should do. So for instance, for a left node, I'm dropping in the X and the Y at 1, but the Y at 1 checks on this side. So maybe not. Maybe this is the most efficient way. So right node and up node. Do we have an up node? We do have an up node. Up node is Y negative. Let's check that's the bottom one here. And X even. X even. Perfect. So our up node is fulfilled. And we need a right node. So let's do that now. We can change the sequence to which they fall after, if it's even necessary. But whatever fits your style. So let's grab the right node's data. So that's top. So right node says plus X and Y even, plus X, Y even. Let's get our data. Actually, we're going to leave the method there. It's easier that way. In copy and paste land. And we're just doing the checking. Okay, oh, let's do a check on that node. So right node takes a +1 on the X and a Y even. Right node takes a +1 on the X and the Y even. Let's get rid of that. So now we're looking for a bottom node, which we already have in code. And the bottom node is the bottom one, so we'll be checking this one. And that's X even and Y plus. X even, Y plus. Excellent. Just double checking to make sure that, you don't have to do this later when it's not apparent what's going on. Right now, I'm doing it. It's apparent. It's no getting around what I can see in front of me. So now we need to check the right node, and that's a plus on the x and a y even. Right node plus on the x, y even. What is bottom? They all seem so familiar. Right node plus on the x and y even. So here we're checking for our right node. So now we can take that down. Beautiful. So this is what we have now. So we have our right node, bottom node. We can do that nice now. Left, right, up, down. Okay, so our left is called twice. Now we only call it once. Our right, again, is called twice because we're checking all the corners. And the bottom and the up. And then we took that other little piece out to set right here. So this is what we got now. Looks much cleaner. I mean, there's a lot more functions pulled out, but it's better this way. This is not being called outside of this class. There's no reason to allow it. Will you need to be able to get a node at that position? Maybe. But right now, no. So until then, we won't need to expose it. So these are all private functions that make things work. I don't really know if this makes things faster or not, but looks nicer.